Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +2348085095144 to learn more and get started today.
So what we are looking at is how you identify whether an equation has no solution, infinite solutions, or just one solution. No solutions, infinite solutions, or just one solution. Or, okay, as we are doing that, we can even demonstrate all of that here, because I told you earlier that you will find a question that would test something I've mentioned to you earlier. I'm actually, when I saw this, I really needed you to see it. For instance, read this. Read number 36. Let me zoom in.
The system of equations above has no solution. So equation to zero, Abby. Wait, I think I can solve that one.
Yeah, we better do, so that we start with this. The equation, the system of equations above has no solutions. Now, what do you do?
Okay, I can try. Hold on, let me.
That's okay. I need to know what you're doing so that I won't waste your time.
Okay.
Because if you're not starting with this, starting on the right premise, your conclusion will be faulty. So you need to start well with the right logic, or I don't want you to get stuck along the way. So what are you trying to do?
Okay, can you show me?
Okay. That is not a sign of giving up anyways, because maybe if I had given you the whole of this year, you would have come up with an answer. I know you don't give up in your family, so let's just say there wasn't much time. Anyways, the system of equations has no solutions. If you remember, I mentioned something like this to you earlier, or perhaps not you, but it seems like I've mentioned something like this. If you solve equations, simultaneous equations by graphical method, how do we identify the solution? Like this is equation 1.
The points where both lines cross.
Yes, excellent. The points where the two lines intersect, or the different equations intersect. Like if this is equation 2, the solution is where they intersect, as you rightly said, which in this case will be here. Yeah, you trace down to x, whatever the value of x is here, and then you also trace to y.
Wait, so if it has no solutions, does it mean that they're parallel?
Excellent. I said it. You will reason it out. If it has no solutions, they are parallel. No solutions, so because we need to understand. I just decided not to just give you the answer like that. I want you to reason. Well, there are a number of issues we want to address now. The issues are system of equations with no solutions. So I will just say system of equations. The first is when it has no solutions. You see, sometimes we don't even need to bother about which direction are we going. Once we start, we know a direction. Something will pop up and we'll be guided. System of equations with number 1, no solution. You've just figured out that for you to have no solutions, they must be, because if they have solutions, they must intersect somewhere. They must cross each other.
They must be parallel.
They must be parallel.
Same gradient with a different.
Exactly. It may be a different intercept. No solution. Equations. Lines must be parallel. Okay. Must be parallel, which, as you rightly said, they must have the same gradient.
Yes.
All right. Which means same gradient, same slope or gradient, whatever you call it in your climb. By the way, slope is how steep it is. If they have the same slope, then it means they are running in the same way, such that they will never meet when you extend on both sides. If they will never meet, they can never intersect. And for them, the two equations never meet, they must have the same slope, same gradient, same slope. The red line and the blue line, as a matter of fact. All right, so that's basically what you're going to apply here. So no solutions means same gradient. So what do you do? It says the system of equations above has no solutions. If a and b are constants, what's the value of a over b? It was as if I read your mind. You know, before you even told me about that question earlier, I said there was something I wanted to show you. So it just happened that we're thinking like somehow before we started the lesson. Okay. Okay, let's go. You told me, you just said that the lines must be parallel, which means they must have same gradient. So what do we do?
Yes.
How do we apply that here?
So, okay, you equate 3 over 4x and, wait, no. Okay, you make by the subject of the formula for the second equation.
Okay, what? But it has to be b. It has to be y, because what you're saying is you rewrite in the form.
Yes. Okay, so you make y the subject of the formula.
You make y set the formula.
After, you now equate 3 over 4x to whatever new value of x there is in the second equation.
Beautiful. So you write in the form y equal to mx plus c, which of course means making y set the formula. Can we just do that in this one without wasting time for both of them? Because you need to. The essence of all that is so that you can identify the gradient, which is m, isn't it?
Okay.
Which is m. So let's write this in the form y equal to mx plus c. Do you know, without wasting time, because I want to just write the answer, you just move half y to the other side. You know. And by the time you have half y, why not just, can I just solve it directly without wasting time?
Yes.
Okay, so that
I don't know how you do it so quickly. Like, I always have to do it step by step.
It's fine, so that you don't make a mistake. So if we wanted to solve it, we would have just written half y, because this will be equal to, before it is the other one, half y is equal to 3 over 4x. Sorry. You know why I moved half y to the right hand side? Because it's negative. I mean, it has negative here. So I'll move it to the right hand side where it will gain a positive sign. And I won't complicate this equation. So half y is equal to 3 over 4x minus 12. If what I've written is going to confuse you, I better write it the other way so that you see it. Half y is here. It's equal to 3 over 4x minus 12. All I did was to move half y to the other side. I think it makes sense. Are you still here?
Yes.
Okay, half y, move to the other side. 3 over 4x is still here. Then I brought 12 across. It became minus 12. You know, I moved half y to the right hand side. Okay, so what do I need to do now to make y set the formula? So I just write it directly. Multiply all through by 2, isn't it?
Multiply by
So that the half will disappear. So y will be equal to, multiplying by 2 will give us 3 over 2x minus 24. So we can easily identify the gradient. What's the gradient?
3 over 2.
3 over 2. So 3 over 2 is just the gradient. The intercept is minus 24. So that's for that first equation. The second equation below, equation 2, make y set the formula. That will be, let's just do that directly because it's not really a big deal. That would be y equal to, okay, if you still want me to do the first step before the other one, no big deal. Here, by will be on this side equal to ax on this side minus 9. And then it turns out that y is equal to ax over b, right? So it's easy. The answers are already showing themselves. Ax over b, I'm dividing both sides by b, minus 9 over b, am I right?
Yes.
Okay, so hasn't it,
A
hasn't
over
it
B
shown?
is 3 over 2.
A over b is 3 over 2 because they must have the same gradient. So a over b is 3 over 2, which are the gradients. So for a system of equation not to have a solution, they must be parallel, they must have the same gradient. Alright, so the answer is 3 over 2. Answer. That's for the first part. No solution.
First part.
No solution. Okay. Now this other part is single, one solution. One solution is the one you already know, you've been working with. If you can find x equal to something, not x equal to x equal to something. Once we can, okay, let me write it, single or one solution, no need for big grammar. One solution for one solution, once we can prove that x is equal to k, where k is a constant. So it has one solution. Several equations we've done are typical examples like 3x minus 2 equal to 2x plus 5. Let's solve. That's an example. What's the value of x here quickly? They won't even give you this one because it's too simplistic.
3x minus 2x.
3x minus 2x is equal to 5 plus 2. So x is equal to 7. Single solution. Now, infinite solution. C. Infinite solution. There can be uncountable solutions. Infinite solution. When you end up getting x equal to x, or a number equal to a number. You hear me? Let me say that again. When the equation simplifies to equations, or the system simplifies to equations simplify to, it has to be equation simplifies to, because by the time you write them, you will get one equation. Something like this. A or I, x equal to x.
Yeah.
Or x, or a constant equal to a constant. X equal to x. Or k equal to k, where k is a constant. I gave you one earlier. Can you read out that equation before we started the discussion proper? The discussion proper.
Which equation?
The one the one I gave you, you said you were trying to figure out how to do it. I think I can remember it. I gave you 2 open a bracket 3x minus 9 equals 4x.
Yeah.
Minus 3.
Yeah.
Give you minus 3 here.
4x minus 6 plus 2. Sorry.
5x minus 9 plus 2x.
4x minus 9 plus 2 plus 2x.
Yeah, so let's solve this. This open a bracket, you have 6x minus 9, isn't it? The other one will also be 4x plus 2x equal to 6x
Yes.
minus 9, isn't it? So, without even wasting your time, once you have this exactly the same thing on the left hand side equal to exactly the same
So
thing on the right
everything
hand
is
side,
equal to 0. Like there's no.
it's not everything is not equal to 0.
Because everything cancels out.
No, everything is not equal to 0.
Okay, hold on.
Everything. I need you to correct this.
See now, 0x is equal to 0. Like 0 is equal to 0. If you simplify.
No, 0x is equal to 0, but everything is not equal to 0.
Okay, let's see.
This is what you are saying. What you should say is 0 is equal to 0. Not everything is equal to 0. I want to correct that, because when you get listen up, when you get x equal to 0, it has a solution. No? The solution is 0. It doesn't have infinite solution. No? It's different from what you are saying, so that we can just draw a distinction. The distinction is, let's solve this. This is 6x minus 6x, isn't it? Collected like terms is equal to minus 9 plus 9, isn't it? So 6x minus 6x is 0x, which is equal to 0. That is different from saying x equal to 0. This is 0x. By the way, 0x means what?
0.
So if you had told me 0 is equal to 0, that's correct. Infinite solution. Because I told you k is equal to k. K is a constant. Or if you also get x equal to x. So, it's just like saying k is equal to k. So, infinite solution. This implies infinite solution. Or infinite solutions simply means the uncountable numbers of values of x will satisfy the condition. If x is 1, it will be correct. If x is 2, it will be correct. If x is 3, it will be correct. X is 1 billion minus 10, it will be correct. So in summary, the way to identify it is, once you have the same thing on the left hand side equal to the same thing on the right hand side, by the time you simplify, you see, you wouldn't even need to keep going, because when if you keep going, you may end up getting x equal to x, or a constant equal to a constant. Because if I needed to go through that route, I would have to help you get x equal to x, I would have done this. So this is alternatively, what I would have done is 6x minus 9 equal to 6x minus 9. Add 9 to both sides, it will be 6x equal to 6x. Divide through by, so that because you need to be convinced. This mathematics is better understood if you see the principle yourself. So what I just did is add 9 to both sides. 9 to both sides. Add 9 to both sides of the equation. Are you still here?
Yes, I am.
If you add 9 to 6x minus 9 equal to 6x minus 9, what will it become? 6x equal to 6x, isn't it? Because the 9 will cancel that. Okay, divide both sides by 6.
Okay, so it's like an infinite. Okay. Right.
Divide both sides by 6. Divide both sides by 6, what will you get?
X is equal to x.
X is equal to x, which proves this. So whether you get x equal to x, or 0 equal to 0, or a number equal to a number, then it is correct. It is like this. It's infinite. It has infinite solutions. So that's that. Okay, so no solution. The lines must be parallel, which means same gradient. Just simplify, write in the form of mx plus c, y equal to mx plus c, the general equation of a straight line, and equate the gradients, the slopes. Like in this case, you have 3 over 2 for equation 1 equal to a over b for equation 2. No solution, because the lines are parallel. They will never meet. They are parallel. They run parallel. They will never meet themselves to form a point of intersection. All right, that's for no solution. Just in summary, for one solution, there has to be a particular answer. Most equations are like that. For infinite solutions, you end up getting x equal to x or k equal to k. I think that simplifies all that. Are we good on that? Okay.
Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to two main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.